Today we're going to perform a combustibility test. It starts out on the watch glass. We place down a reagent paper strip RE2327 onto the watch glass so it sticks off the edge or extends off the edge just about by 1/8 of an inch. We then soak the reagent paper strip from end to end with the unknown, and then we add 48 drops into the center, which is about 1 pipette full, 2 milliliters. We take a match and we're going to try to ignite it from the end of the reagent paper strip that's extending off the edge of the watch glass. And if we have to, we'll hold the match there for 3 seconds. Let's see what happens with this first unknown. Oh, I don't know if you saw that, but it seemed like the flame actually jumped from the match before I even touched the paper and ignited the entire pool of liquid almost. We would consider that an extremely flammable liquid. It's burning very clean with a yellow flame and sort of a pink purple base to it. I'm going to let it burn to completion because I want to see if it's mixed with anything. If it's pure, if it's a pure flammable solvent, it should burn to completion and not leave any residue behind. If this was a solvent that's mixed with water, let's say, then at the very end, once the flammable liquid burns off, there would be a liquid residue left over in the watch glass here in the bottom. If there's something solid mixed in, some inorganic solid perhaps, that could be plated out on the watch glass as a residue. So we'll watch it burn to the end. This would happen to be acetonitrile. It has a flash point less than 140 degrees Fahrenheit, so it's definitely classified as a flammable liquid. Alright, no residue left behind, must have been pure. Let's try another one. Just rinse my watch glass here. This time we'll take a liquid, soak it from end to end. This one's a little more viscous. And once again, 2 milliliters, about 48 drops of the unknown to the center of the watch glass. I'll hold the match to the end of the paper that it's extending off the edge of the watch glass by 1/8 of an inch. If I have to, I'll hold it there for 1/1000, 2 1,000, 3 1,000. Doesn't seem to ignite. I will try to touch the, oh, there it is. It's actually lit. Hard to see it. If it doesn't immediately light the pool, then we'll take a new match. I don't know if you can see that, but it actually is burning off the end of the wick there, the reagent paper strip. If it doesn't immediately ignite the pool, we'll take another lit match and we're going to touch it to the actual pool to see if we can get it to light. And we're going to try that by touching it to there for 3 seconds if we can. 1,000, 2 1,000, 3 1,000. Alright, try that. We are burning off the end of the wick here. We would allow this to burn to completion. It's going to take a long time. But eventually all of this liquid will wick its way up the reagent paper strip and burn off the end. It's burning very clean with a blue flame. So this would be considered a combustible liquid, a flash point greater than 140 degrees Fahrenheit. I'm going to go ahead and let that burn to completion so you can see what happens. So if this didn't light the first time, I would try it again with a new match. So we try it twice, and then we try to ignite the pool twice as well by holding a lit match to the liquid of the pool. Even if the liquid is hard to burn but the entire pool catches fire, the flame extends over the top of the liquid, then it would be considered a flammable liquid, at least a flash point less than 140 degrees Fahrenheit. If it only burns off the wick and never burns off the pool, then it's a combustible liquid, a flash point greater than 140 degrees Fahrenheit. I don't know if you can see that. Move it around a little bit, try a different angle. It's barely burning the paper. It's really just burning the liquid, as this is acting as a wick. Once again, almost a completely blue flame, tiny orange yellow top to it, and the amount of liquid is slowly reducing. This will probably burn down on the top of the wick until the liquid is consumed. So the first one we saw was extremely flammable. The entire pool ignited before the match even reached the edge of the watch glass. That could be a liquid that has a flash point below 74 degrees Fahrenheit. Very flammable is when the flame quickly runs down the wick and quickly spreads over the entire pool. A lot of times you'll have a flame that'll propagate up about 2 inches or so. Flammable is when it'll burn off. It'll start burning at the end of the reagent paper strip here, and it may slowly make its way down, but eventually it will burn off the pool. There'll be flames actually coming off just the liquid itself. Then we consider that flammable. I mean, just under 140 degrees Fahrenheit. And then last but not least, we have a combustible liquid with a flash point greater than 140 degrees Fahrenheit. And we're burning just off the wick itself. The flame never extends and burns off the liquid in the pool. Of course, a substance could be non-flammable, in which case the paper will never ignite, the liquid won't ignite. Oftentimes it will actually extinguish the match. Okay, we can see that the amount of liquid is definitely disappearing, slowly diminishing. A little bit more of the paper started to burn. That's why the flame's increasingly a little bit more yellow. So I'm going to call this one. I don't see any residue built up where the unknown is. It'll eventually wick this up and burn that off as well. Alright, let's try another one. Alright, we'll take a new reagent paper strip. Once again, we lay it in the watch glass so that it extends off the edge by 1/8 of an inch. We'll soak it with our unknown liquid from end to end. And then we need a puddle in the middle. 48 drops, which is 1 full pipette, 2 milliliters. We'll take a match. We're going to try to ignite it off the edge of the wick here, and let's see what happens. There. Alright. So the wick lit. It kind of ran down the wick and eventually ran out onto the actual pool of liquid. This is a very unusual appearing flame. It's almost completely white-gray in color. I would say this is definitely a flammable liquid. This happens to be what we call nitromethane. Very unusual, distinctive flame. Definitely a flammable liquid because the pool is burning, not just the wick. The wick hasn't even started to burn yet. The liquid's burning off, not leaving any residue behind. I'm looking for that. It burns very clean, no smoke. So here we have a flammable liquid, flash point less than 140 degrees Fahrenheit. We go ahead and let it burn to completion. Kind of disregard any of the char that builds up when the paper starts to actually burn itself. We don't consider that a residue. We're just looking here for residues that would build up. Alright. Take our reagent paper strip, lay it in the watch glass, extends off the edge by 1/8 of an inch. Take our unknown and we soak it from end to end with the unknown liquid, and then we fill the center of the watch glass with 48 drops, 2 milliliters, 1 pipette full of the unknown substance. We're going to try to ignite it from the edge of the reagent paper strip, and let's see what happens. Oh, there we go. And we can see that the entire pool ignited fairly quickly. This time we have a very dirty burning solvent. I'll get out of the way here. a completely orange flame. Lots of what we call Texas snowflakes or black spider webs in the smoke. It burned off the pool in addition to the wick. This color flame, the orange and the black soot in the smoke, indicate that this compound has a benzene ring in it. It's an aromatic hydrocarbon. This particular one had a flash point less than 140 degrees. It is a flammable liquid. Alright, that's our combustibility test for today.